Okay, so finally, let's say we want to solve a differential equation. We want to use Sympy to solve a differential equation. So we want to use Sympy to solve an ordinary differential equation. Let's start off with something simple. Let's start off with the derivative. Let's say that our unknown function is going to be called u, and we want to solve u prime is equal to u. So we will solve u prime of x is equal to u of x. Pause the video for a moment and remind yourself what the solution is to this equation. Okay, all right, we'll have it here. Again, I'm just kind of writing this because I want what I'm doing here to somehow be related to this. Obviously, the quadratic functions are no longer relevant to what we're doing here. Okay, so our independent variable is going to be x. Our unknown function is u, so we're going to call this a function. So sp.function like this. Whoops. And then I'm going to say du, that's going to be the derivative, and I'm going to write sp.diff. And to do this, I need to write u of x and then x. So this says take the derivative of u of x with respect to x. And now my differential equation, my differential equation is u prime is equal to u. So it's going to be du is the left-hand side of the equation. U is the right-hand side of the equation. Now my solution is going to be sp. So instead of solve, it's going to be desolve because we're solving a differential equation. And we're going to write deq. That's the differential equation that we want to solve. And then we're going to write u of x. Remember, you need to write the u of x. For the functions, you basically always need to write the argument. And this is going to solve this equation for u of x. And then we will print the solution. And I'm about to tell you the solution. So if you want to think about it more, pause the video now. But the solution should be some arbitrary constant times e to the power of x. So let's run it and see what we get. Aha, well, that's great. What did I do wrong? Well, so remember when I said you need to have the x here, you need to have the x there. And this is what it is. So it returns an equation, and what this is saying, this is an equation, and what it's saying is u of x is equal to e to the power of x. All right, sorry about that. Got a phone call. Not sure where I am. So what is actually getting returned is an equation, and it's saying that, remember, an equation has two components, the left-hand side and the right-hand side, and it's saying u of x is equal to c1 times e to the power of x. Sorry, I keep getting phone calls. So let's see what happens if we do pretty print. Okay, maybe that looks a little bit better. I don't know. So the other thing that I want to show you is a second order equation. So let's come up here. Let's say we want to solve u double prime is equal to minus u. Okay, pause the video for a second and try to remember what the solution here is. Okay, maybe you're back. Maybe you looked that up. So now what we need to do is we need the second derivative. And really, to get the second derivative, we just add another x. So this says take the derivative of u with respect to x, and then take it with respect to x again. So you can also do partial derivatives here as well. So I also like to add 2d's here so that I know that I'm working with a second derivative. And now when I solve this, now when I run everything, I should get a linear combination of cosines and sines. I need to have minus u here. Okay. So here I get a linear combinations of cosines and sines. The one that I had before was u prime is equal to u. Do a minus sign, you get c1 sine plus c2 cosine. Okay, so this is solving differential equations using Sympy. Again, I don't know how many of you guys are going to be solving differential equations kind of in class. I'm not exactly sure what gets covered in AP calculus classes and who's teaching maybe a differential equations class at a community college. But I like it if I think it works well, and I think it's interesting. At any rate, this was it. This is our last video for Jupyter this week. I hope you have enjoyed them or have learned something from them.